So what we're going to look at today with quadratics, there's two different forms that you can write them in, standard or general form, and then what's called vertex form, or sometimes it's called transformational form, because you can see what the transformations are and how to go backward and forward between the two. All right, so here's what they are. First one, your standard or general form. F of x equals, they're all going to have f of x equals function. Ax squared plus bx plus c. So you have the squared term and then just the x and then the constant, like just the number that's left over. And then your vertex form. It's f of x equals, that's an a out front, x minus h squared plus k. The reason it's called vertex form because you can see what the vertex is, and also transformational form because you can see what the transformations are. This a value would be like your vertical stretch or shrink. And then this would be left or right h amount and then up or down k amount. I know you're like, but it's plus k, so would that be up? Yeah, but what if k was negative? Then it would be down. So, it's like whatever sign that number is. So your vertex would be the points h comma k. Let's pretend both of those values are positive. It would have gone right h and then up k. So for example, and I'm just gonna like draw a parabola here. This would be your point hk, and that would be your center point, your vertex. That's what we call the vertex, that middle point. And then the other characteristic that we want to look at is called the axis of symmetry, which don't overthink that. Symmetric just means same on both sides. The axis of symmetry is that vertical line that cuts the parabola exactly in half, which it's nice to know because then when you're graphing, you get that buy one, get one deal with the points. And we've been doing that. You have a point on one side, you can graph the same point on the other side, like work smarter, not harder. Since it's a vertical line, it's always going to be x equals, and it will be that h value. So like whatever that is. And I know it kind of doesn't make sense until you do a problem and there's actually a number in it. But like say it was 2, it'd be x equals 2. And then your vertex would be 2 comma whatever. So whatever number that is, that kind of gets repeated. But it's nice to know where the center is. Now, I'm not going to sit here and say which version of the quadratic is better or worse. It's not like a contest between them. Kind of depends on what you want to do. If you want to graph, vertex form would be better, right? Because you can use the transformations and get a graph real quick. Let's say you wanted to factor it though, then the general form might be better. So it just kind of depends on what you want to do. And what we're going to practice today is going backward and forward between the two. So 1, 2, and 3, it says write the quadratic equations in standard form. So right now they're in vertex form. And actually, let's go ahead and state the transformations. It's not asking that, but I'll throw that out there. How did this one get shifted? Left 8, good, and then down 3. So your vertex would be -8, -3. Are you following me there? Like, okay. But what we're going to do is rewrite it in standard form. So the x minus 8 squared, you're going to have to, x plus 8. X plus 8 squared, you're going to have to write that twice. I call it a twin. There's 2 of them. Squared means you've times it by itself. Pep talk. This is just about not being lazy. You just have to write it out. Do you guys remember FOIL? First, outside, inside, last. See heads nodding. Nice. We're just going to distribute everything to each other and combine the like terms. So here we go. X times x. X squared. Good. Now try and do the outsides and insides together. The outsides are 8x. The insides are 8x. So together, 16x. And then the last 8 times 8 is 64. And then you have that -3. And then your last step would just be to do the 64 minus 3. And if you want to just do that in your head, so you don't have to write it all out again, then that's fine. This would be plus 61. That's really all that there is to that. It's just a bunch of multiplying. So if you can multiply numbers, it's more about organization than anything else. All right, this one I did stick a 2 out front though, so be careful with that. I would still write it out twice. That x minus 4 is being squared, so just write it twice. Just don't be scared of writing a little bit. It's not that much, you can do it, go team. And so that 2 is just going to sit out front there while we distribute everything to each other. So again, it's first outside, inside, last. X times X will be X squared. And then I'm going to draw in the little rainbows. Try and do these together. What would that give you, the outsides and the insides together? Good, negative 8X. And then negative 4 times negative 4 will be positive 16. Then that minus 7 is just there. He's like, hold on, wait, I'm here too. All right, so then we're going to distribute the 2. So just double everything in there. So it'll be 2x squared minus 16x plus 32 minus 7. And again, if you want to just do the 32 minus 7 in your head and go ahead and write that so you don't have to write the whole thing again. I'm doing the problem in front of a whole group of people though, so I'm going to write it all out every time so you can see it. But 32 minus 7 be 25. All right, and we're just going to try one more. Do you guys feel like you want to try this one on your own? Okay, I'm going to pause the recording. All right, so that negative 3 is just going to like wait patiently out front. We have x squared. The outsides and insides together will give you negative 2x, and then negative 1 times negative 1 is positive 1. But then we're going to distribute a negative 3 into that. So that would be negative 3x squared plus 6x minus 3 plus 5. And so what number are we going to have at the end there? Good, positive 2. All right, if you missed a negative sign, that's an easy thing to fix. Just be careful. Negative signs are slippery little doubles. They're just the most commonly missed thing ever. You just got to be careful with them. Just remember, when you multiply 2 negatives, it turns positive. So if you square a negative number, it's going to turn positive. All right, what I want to do with the next 3 is factor them. Again, we aren't going to cover factoring as its own topic in this class. It's an understood skill you come in with, but I do understand that last year was crazy with Algebra 2. Some of you took it first semester, it was a while ago. So anytime we do some factoring, I'm just going to try and do it a little bit more slowly than I would normally. I'm going to, again, pause the recording. I want you to try to factor these 3. And again, talk to the people around you and share your answers and see what you get. Just try to factor them. And it's going to start out like this. Like you're going to draw your 2 empty sets of parentheses. It apart. So for this one, you're breaking it apart. So the x squared is going to be x times x. And then you need 2 numbers that multiply together to be 16, but add or subtract to be 8. So what did you all put? 4. And you would need to add them because 4 plus 4 is 8. Now you want to stop and go, what do you notice? I call this a twin. Do you see how it's double? All right, so you can write it as x plus 4 squared. What we're gearing towards, and it's not going to happen immediately, but where I want you to eventually end up after you do enough of these is that you can skip that middle step and make the leap straight to the answer. I want you to start to notice it. Again, I'm not expecting that to happen like immediately, but that's where we want to kind of head. All right, so this one, how did you split the 36? Yeah. Good, 6 times 6, and this time they need to be negative. Negative 6 and negative 6 will get you negative 12. Hey, it's a twin, x minus 6 squared. And then this one, same thing. How did you split the 25? 5 and 5, positive or negative? Both negative, and so it'll be x minus 5 squared. So I'm going to give you a chance to try these. I'll pause the recording again. What I want you to do is figure out what number needs to go on the blank so that it will end up being a twin and you can write it as something squared. That's the goal. So you need to figure out what number would need to go on that blank so that you could factor it and it would be a twin and you could then write it. And I want you to write it as something squared. Talk to each other. You've been doing a good job of that. Talk to each other, give it a try, and then I'll go over them. So what'd you guys put on the first line? 9. And so it would split. And if you wrote the middle step, that's fine. I'm just trying to get you to like make the leap towards the answer. It would be x plus 3 times x plus 3. So it would be x plus 3 squared. All right, how about this one? What'd you put on this line? All right, 49. And so in the parentheses, it would be x Good, -7. The symbol here, plus or minus, is just gonna match what's in the problem. This one's kind of a little tricky. Good, it's gonna be 1, because 1 and 1 makes 2. People forget about 1 because it's just 1. And so in here, you'll have x minus 1. -1 and -1 will make -2. What do you notice that all three of these numbers have in common? Like, what is the same? They're all positive, so you're always going to add, and they're also all what? They're perfect squares. Do you guys know your perfect squares, like 9, 16, 25, 30? Let's write them down because they'll be good to know. Don't forget about 1. 1 squared is 1. What's 2 squared? All right, 4, 3 squared is 9, 16. Let's see if we can go up to 12 squared, okay? What would be next? All right, 25, 36, good. 49, 64, 81, 100, good. Does anyone know 11 squared? Oh, good, 121, 144. They keep on going forever. Obviously, numbers are infinite, but if you know them up to there, you'll be in good shape. All right, so to complete the square, and we'll just do a couple of these and then I'll give you guys your brain break, all right? What you do is you take this middle coefficient, divide it by 2 and square. So your middle coefficient, divide by 2 and square. So we're writing that out officially, but you guys all figured it out just using your math instinct, like your basic number sense. When I said, hey, figure out what number goes on that line, you all figured it out. But here's what you did. You took this 6, divide it by 2, that's 3, and then 3 squared is 9. Same thing here, 14 divided by 2 is 7, 7 squared is 49. 2 divided by 2 is 1, 1 squared is 1. So that's what you're doing. You take your middle coefficient, divide it by 2 and square it. All right, so whenever we're gonna do these, first step is you wanna subtract that 8 to the other side and leave a little blank. Do you see how I left a blank there? Because you want to add on whatever number to complete the square. And actually, you know what? I'm going to make it a different color. I don't know how well it'll show up on the projector, but I'm going to make it purple so that you can see it and it looks different. So leave a little blank there. Now you want to complete the square. So what number needs to go in that blank to complete the square? It's the same thing you did with 7, 8, and 9. Good, 4. So plus 4. And whoever said it's always positive, nice job with that. When you square something, it's always positive. It will always be adding. Now, if you add to the left side, you also have to add to the right side. So if you put the plus 4 on the left, oh, you can kind of see that that's purple. It's a little bit of a different color. All right, now the point is that you can then write this as something squared. And again, if you're not there yet, that's fine. You can break it into 2 and then write it as the next step. But what is going to go in these parentheses? X plus 2 squared, good, equals, and then on this side, -8 plus 4 will be -4. So that's what we're looking for. All right, so let's try that again for this one. You're going to subtract the 1 to the other side, leave a blank there. And then you're going to figure out what to add. Again, it's always adding. Thank you, whoever said that. That's good. Always adding. What are we going to add for this one? Good, 9. And if you add it to the left side, you also have to add it to the right side. So plus 9 on both sides. So what will go in these parentheses? Good, x plus 3 squared equals, and then on that side, you have -1 plus 9, which would be 8. I'm going to make up 2 more for you to just try real quick. Then we'll do our brain break. Because after these, they start to get a little bit harder, but I wanted you to try a couple more sort of easy ones. Go ahead and write down those 2. Just try them real quick, share with the people near you, and then I'll go over them. All right, so for this one, you're going to subtract the 7 over, leave a little space, What did you guys add? Good, 25. That's the hardest part, deciding what you're going to add. All right, and then what's going to go in the parentheses there? Something squared. Get x minus 5 squared, and then negative 7 plus 25 gives you 18. All right, and then this one, we're going to add the 5 to the other side. What did you add on for this one? Again, you want to divide by 2 and square. Good. Do you feel like some of these are redundant? Like, hey, we already saw the 9 and the 16. Well, there's only so many perfect squares I can give you. Like, I know these go on forever, but it's going to be one of these. So you're going to see the same numbers over and over again, which is actually kind of comforting to me. Like, that's one of the things I like about math is like, oh, this is it. All right, so this will be x minus, what will go there? Good, x minus 4 squared equals 21. All right, so I'm not changing the process with these next ones. They're just gonna sometimes have a fraction in them, which I know can be scary for everybody, all right? The reason it's gonna have a fraction is the first thing you wanna do with that middle coefficient is divide it by 2. And so if you have an odd number, you're gonna end up with a fraction. All right, but we're gonna do the problem the same way. First thing you're gonna do is subtract that 3 off to the other side. So leave a little space, it'll be minus 3, it's no different. What I usually do is write this off to the side, like as a mental note for myself. What I want to do is take this 7, just watch me do this. I'm going to write the 7. I want to divide it by 2 and then square it. So I'll just usually write that off to the side. I want to take whatever number that is, put it over 2 and then square it. You will still end up with perfect squares. They will just be a fraction. All right. What is 7 squared going to give us? 49, and 2 squared, 4. So what we want to add, if you want to make it a different color, is 49 fourths. Spoiler alert, it's always going to be fourths. Always. If you add something that's not fourths, you have goofed, because you should divide by 2, and 2 squared is 4. Does that make sense? Like we all together there? Should be fourths. All right. So what's going to go in these parentheses? Something squared. Will it be x plus something or x minus something? First, let's get that. Good, plus, because it's just going to match whatever symbol's there. It'll be x plus whatever number you wrote off to the side. So in this case, 7/2. Don't discriminate. That's a great answer. People get all upset that there's a fraction, right? 7/2. Now here we have to get a common denominator, which is going to be fourths. We have to make this be fourths. Now it is going to be negative because it was a -3. So here's the question. How many fourths is a whole 3? 12. So it's -12 fourths. This is just basically a review of adding and subtracting fractions. You have to get a common denominator. So it will be x plus 7/2 squared equals how many fourths? Well, you just have to do -12 plus 49. So what is that going to be? 37 fourths. So we did not do the problem any differently. It didn't seem like anyone panicked there, but let's try another one. Just write it off to the side as like a mental note for you, and it will always be fourths. If you add something other than fourths, you had a mistake. All right, so this one, first step, you're going to subtract that 2 to the other side. So you'll have a -2 over there. Now I know the 3 is negative, but I would just off to the side, just write 3. We know we're going to put a negative in the problem, so don't overcomplicate things. We're going to take 3, we're going to divide it by 2 and square. So just put it over 2 and square. And I'll do this in purple. What do we want to add on? You just want to square each of these numbers. Good, 9 fourths. So you're going to add 9 fourths to both sides. So in these parentheses, it's going to be x minus whatever number you wrote off to the side, which in this case is 3/2. If you've written it, then you're not going to forget. So just write it down. So x minus 3/2 squared equals, now I need to make both of these fourths. It is always going to be fourths. You're going to like get sick of fourths when you do the fraction. It will always be fourths. Now this is going to be negative. And how many fourths is 2? 8 fourths. All right, so it will be x minus 3/2 squared equals, and what will go on the other side? 1/4. Is that okay? Okay, it will be fourths. All right, and then these ones, I put a coefficient out front. All right, it's going to start out the same way. The first thing you would want to do is subtract over that 241. So you're going to subtract that to the other side. And I know right there, a lot of you are like, oh my gosh, that's such a big number. It's going to be okay. On this side, we moved over the 241. From what's left, you need to factor out the 3. Do you remember GCF, like dividing out a number? So we're going to divide out that 3. You would be left with x squared plus, all right, 54 divided by 3. Let me see, what is that? 18x plus, now here's where we're going to divide by 2 and square. This is completing the square. You did fine with it on the other side of the paper. This problem's a little bit more complicated, but I believe in you, all right? You just need to take 18, divide it by 2, and square it. What's that going to give us? Good, 81. Well, let me make that purple. We're going to add 81. And here's the only kind of tricky thing. We're not going to add 81 on the other side because it's really 3 times 81. Heads nodding. You guys saw that coming. It's 3 times 81, which 3 times 8 is 24, 243. So it's going to look like you added a different number on each side, but just remember this one was times 3. So we did add 243 to both sides. All right, so what would go in the parentheses when we have something squared? It'll be x plus what? And then squared. Good, 9 equals, and then negative 241 plus 243 would be 2. If you're like, hey, that was kind of a lot, I need another example, I've got you. I've got one right here. All right, first thing we're going to do is add that 1 to the other side. I'm going to move that over a little bit so I have a little bit more room. We're going to add that 1 to the other side. So that's taken care of. From what's left, you just need to factor out a 2. So that would leave you with x squared minus what? We're dividing out a 2 here. But good, nice. And then plus, you get out the purple pen here. You want to divide by 2 and square. So take 14, divide it by 2 and square it. Perfect. But it's not going to be 49 over here because remember that 2 out front, it's really 2 times 49, which, what is that, 98? Thank you. So we want to add 98. I need you guys to back me up when I do the mental math because like, if I just multiply wrong, then it's going to be wrong. And like, people don't stop me. They'll just let me keep going. They're like, well, we trusted you, Ms. Cole. Trust me, but also if I mess up, please tell me. I'm human. I want it to be right. All right, so this is going to be 2 times something squared. In the parentheses, that'll be x minus 7. And then over here, 1 plus 98 be 99. So if there's a fraction or if there's a coefficient, you do the problem the exact same way. Just for a fraction, write it off to the side. And if you have a coefficient, just remember to multiply that together there. All right, so the whole point of doing complete the square and what we just practiced there is to be able to get it into vertex form so you can graph it really easily. Whenever I do complete the square, this lesson always goes really well and people notice the pattern. They're like, oh, I really understand this. And then on the test, the directions will say, put the quadratic in vertex form, and half the class will be like, what does that mean? It means complete the square. So it's the thing that you just did with no problem. It's just gonna have an f of x equals in front of it. So instead of like moving that other number, that constant to the other side of the equation, we're gonna kind of leave it where it is because we have f of x equals. But we're not gonna do this any differently. X squared plus 6x plus what? What would have to go there to complete the square? 9, good. Exactly like we did on the other side of the paper. So here's my suggestion, give that a hug. And then what you have to do is maintain the integrity of the problem. And by that, I mean, you can't just go around changing an 8 to a 9. Like you're not allowed. I have people try to do that on tests. Like, I don't think I like this number, and make it something else. It's not going to work, right? I have to turn the 9 back into an 8. And how would we do that? -1. Good. It just, instead of moving it to the other side of the equal sign, we just kind of left it where it was. And then the whole point is that you can write it as something squared -1. I'll usually write this, I call this like the framework or the skeleton of the problem. Kind of do that, and then you can just fill in the blank. What will go in that blank? Yeah, x plus 3. I think that's the third one today we did that was an x plus 3 squared, and you had a 9 there. Again, it's going to get redundant because there's only so many numbers I can give you. All right, so how did the graph shift? That's the point, is now we can tell the transformations. How did it move? Left 3 and down 1. So we're going to go left 3, down 1, put a point. That's your vertex. You couldn't see what that was or tell what any of the transformations were when it was written like this. That's why we rewrite it. It was 2 whole steps of work. Then you get that center point. Now your axis of symmetry is going to go through that point. It'll be x equals -3. Ms. Cole, will it always be x equals? Yes, because it's a vertical line. That's the Vux part of Poiseuille. So we just need to get a couple of points on either side. And again, it'll be a buy one, get one deal. So what do you want to plug in? Let's make a little table. -2, let's try that. And then let's also do -1. You can plug into whichever version of this you want. I think the Vertex form is a little easier. That's my suggestion. So I would plug into this one. So if you plug in -2, -2 plus 3, 1 squared, 1, and then 1 minus 1, 0. So you get -2, 0, and then across that axis of symmetry, you can put the buy one, get one point. Oh, to be clear, that's not an asymptote. Do you guys realize that? Like, it's technically not there. I just dotted it in so you could see it. All right, and then -1 plus 3, 2, right? Squared 4 minus 1, 3. So -1, 3, and then the same point on the other side, and there's your parabola. There you go. So it's a lot easier format to graph from. That's why we do that. This one has a negative out front, or a -1, if you will. If you want to put a -1, that's fine. We need to factor that out. But only from the first 2 terms. Remember that third term, we're going to adjust that anyway. So just from the first 2 terms, we're going to take out that negative. If you take out the negative, that'll leave you with positive x squared minus 8x. And here's where you complete the square. What are we going to add on? You want to divide by 2 and square. Good. Perfect. You got it. 16. Now you have to maintain the integrity of the problem. You can't just go around changing it. We actually have not a 16, but it's -1 times 16. So it's a -16 that we need to turn back into a -12. Count on your fingers if you need to, but what do we need to add on to that? 4, good. -16 plus 4 will give you -12. You can't just go around changing the problem. And then the point is you can write it as something squared. So if you want to write out like the framework of the problem, just leave it blank. It's going to be negative blank squared plus 4. And what will we put in the blank? Yep, good, x minus 4. Here's the whole point. Like, why did we do that? How did it get shifted? Right 4, good. Up 4. So we're going to go right 4, up 4, put a point, and that's your vertex. And so what would be the axis of symmetry? Yeah, x equals 4. It's kind of nice when they're the same number because you can't mess it up. So we want to plug in some other numbers. What do you want to plug in? 3 is good, and then we'll also do 2. Leave 3 and 2. I think it's easier to plug into this version. It's up to you, but I think this is easier. 3 minus 4, that'd be -1. Squared would be 1, and then you immediately make it negative again. So -1 plus 4 would be 3. So we get 3, 3. Same point on the other side. And then 2. 2 minus 4 would be -2. Squared would be 4, but you're going to make it negative. So -4 plus 4 will be 0. Are we surprised it's upside down? We shouldn't be. Why not? There's a negative. Reflect over x-axis. All I'm saying is if you got a right side up parabola, I hope you would go, oh, whoops. Do you know what I mean? Like you would catch it and then be able to fix it. All right, one more. F of x equals, we're going to have to factor out the 2, but only from the first 2 terms. Because remember this plus 19, we're going to adjust that anyway. So kind of just cover that up and ignore that. When you factor out the 2, what are you left with? Good, x squared minus 6x, and here's where you complete the square. What are we going to add on? 9, good. Now here's where you have to maintain the integrity of the problem. We didn't really add 9. What did we add? 18, good, 2 times 9. We have to turn an 18 back into a 19. So we're going to add 1. And so if you want to write out like the framework of the problem, this one has a vertical stretch. So expect it to be narrower. And in there, we're going to have x minus 3. Here's the whole point. How did it get shifted? That's why we did that. Right 3, up 1. Good. Go right 3, up 1. And that's your vertex. And so what is your axis of symmetry? X equals 3. You do have to put the x equals. All right, and then let's plug in some more numbers. I would plug in 4 and 5. We're centered at 3, so plug in something near 3. I know you guys are fading on me, so I'm going to talk you through it. You have to do more than one example to get the hang of it, though. I can't just do one and expect you to be good. We got to do a few. 4 minus 3 is 1. Squared is 1. 1 times 2 is 2. And then plus 1 will be 3. Thank you. Oh, and look how it's a little bit taller. This might go off the grid. I'm not sure. I don't remember. Let's see. 5 minus 3. Oh, you did it already. 5 minus 3 is 2. Squared is 4. 4 times 2 is 8. Plus 1 is 9. So 5, 9. And yeah, my grids only go to 8. So it went off the grid by 1. You can all handle it. All right, I'm going to real quick share my screen and just show you what your homework is going to look like. Oh, also, I put this optional factoring practice on here. If you want practice factoring, that is there for you. All right. So first thing in your homework, all it's going to ask you for is what number you need to complete the square. If it is a fraction, it will be fourths. It will be something fourths. All right. Now this one's going to be a whole number. Let's just do 1 or 2 of these together. You're going to take the 20. Divide it by 2 and square. So what is that going to be that goes right here? 100. Yay. Let me see if I can get one that has a fraction. That one's not going to be a fraction. Let's do that really quick though. 10 divided by 2 and square it. 25. I want to do one that has a fraction. Give me a fraction one. Okay, this one will be 13. You want to divide it by 2 and square. You might not know 13 squared off the top of your head. If you did want to pull a calculator out for that one, I want you to know up through 12, it's 169 fourths. But it will be whatever fourths. Okay, let me go back. Then the second thing was complete the square. I made all these ones even, so you won't have any fractions here. But please get out a piece of paper and write it down. Don't try to do this in your head. But it's going to be exactly like I showed you on the paper. You'll have something squared equals a number, okay? And then the last one is the first thing we did. And again, you're going to need a piece of paper. Don't try to do it in your head. You're going to write x plus 8 twice, do FOIL, first outside, inside, last, distribute it all together, and then get your answer. Okay.